day, grade 11s and grade 12s, and welcome to today's maths lesson. The title for today is Interpretation of Graphs, and specifically where we need to calculate the two functions, the product of two functions less than 0 in a graph environment. So just stay put. I'm going to my desk now and we're going to do two examples from there. For which values of x will fx times gx be greater or equal to 0? Right, the first thing that we need to remember is actually fx is a y value and gx is also a y value. So if we multiply these two, then we can get an answer of 0. But the question is, where, if I should multiply these two functions, where will they be greater than 0 for a specific x value? Now, let's just clarify first where is positive and where is negative. If this is my Cartesian plane, we will see that we're talking about the y value, sorry. So above the x-axis over here, that's where y is positive. And below here, this is where y is negative. So we're going to work according to that. We're going to slowly through this method to see how we're going to do this. Now, let's start with a table over here. Perhaps in the exam you will do it much quicker than this, but let's see how it goes. We have an fx and we have a gx. And first of all, that we're going to do is to find the x-intercepts. The x-intercepts. Those values are my crucial or critical values actually. And that is where y is equal to 0. So what we have here, you see there's an intersect of the straight line of g at -2 over there. And we have x-intercepts of my parabola over here of -1 and 5. Now just remember, my x-axis, that is where y is equal to 0. That's why we're working with the critical value of equals to 0 to determine my critical values. So first of all, let's have a look at my parabola over here. Where is it equals to 0? And we will see it will be at -1 and it will be at 5. That is where my parabola will be 0. If we look at G, my straight line, we will see it intersect here at -2, so gx will be -2 or will be 0 at -2 then. Right, that is crucial to know where my critical values will be. So now let's see where we're going to start to check where f is positive and g is negative, or the other way around, because we're working with a greater than sign over here to determine the positive value of those two. So let's first have a look at fx then. We want to see where it is positive. Now remember, it is positive if we write it as greater than 0. Right, above my x-axis, that is where it is positive, and below my x-axis, that is where it's negative. My parabola, we have a look at this over here. Now we will see there that my parabola is negative, but there it is positive. It's above. So we will see there's my critical value over there. So it is to the right of -1. Okay. So x greater than -1. And we will stop over there to the left of 5. That is where the fx is positive as well. So this area over here being defined by x greater than -1 and x less than 5. Let's do the same with gx as well. Where is g positive as well, greater than 0? Well, above the line. So this is my critical value over here. So there it's negative, but there it's positive because it is above my x-axis. So very easy, we just say it's where x greater than -2, right? Okay, so let's check where is those functions negative then, meaning less than 0. Okay, we can go quick on this as well. If it was positive to the right of -1, it will be negative to -1. So x less than -1, that's where it's negative. And if we go past 5, we will see the parabola just drops more to the negative side. So it will be where x is greater than 5. Okay, the same with my gx as well. If it's positive to the right of -2 there, it will be negative left of -2. So meaning x less than -2. Now, what we're going to do now is to see how this product of ours will play out. So we're looking for an answer over here that is positive. Okay, greater than 0 means it's positive. Now, if I have two values that I multiply with each other and I get a positive answer, that means if I multiply a positive with a positive, I will get a positive answer. Or if I multiply a negative with a negative, I will also get a positive answer. Now, let's do this. Let's draw a number line to help us with this. And we indicate our critical values. And it's my critical values will be at -2, there's a -1 and a 5. Good. Now let's do the following. Let's choose our critical values for my parabola over here, -5 and 5. And we're going to work with a closed dot over here. That -1 and 5 over there. Just keep them in a straight line. And my gx, the value of that, let's just put it a little bit above. You'll see why we're going to do that now. Good. Now, what we're looking for is an overlap. Let's check that's going to work with. Right. So we're going to take a positive of fx and we're going to indicate it in there. Now, the positive of fx in this case is this little block over here. So we will see it's where x is greater than -1, meaning we're going to that direction, and x is less than 5, going that direction. So this is my solution between -1 and 5. Okay, the positive of gx, let's choose that one over there. So x greater than -1, and you will see it is over there. There is x greater than -1. We're looking for an overlap, and we will see my overlap is nicely shown over here. From -1, there's my overlap over here. That part over there. So let's write my x values. So we can write x is element from -1 to 5 over there. And we're going to make use of square brackets, meaning we're including the -5 under 5 because we have an equal sign over there as well. Right, let's do with the negatives as well over here. If we multiply negatives, number line, there's -2, there's -1, and 5 for my critical values. Now let's see. X less than -1. It is to the left of -1. And x greater than 5, it's to the right over there. And x less than -2. Okay, let's see. There it is. And again, we are looking for an overlap. Right, and where's my overlap over here? Okay, here it is. We will see there, and there's my overlap. So let's write the x values. So x is element from negative infinity, remember it's coming from the negative side, all the way, and up to minus 2, okay, for my infinity sign, always an open bracket, and it will stop exactly at minus 2. Remember, we're working with the equal sign as well. Right, and that is my answer. I can just rewrite it. X element of minus 1 to 5, or x element from minus infinity up to 2. Right, that was for f times g greater than 0. Let's, just for some practice, let's try to see how it works if we got fx times gx less than 0. Let's see if we can work according to that as well. I'm going to use the same table over here to determine that. Now, just remember, to have a negative value over there, we need to multiply a positive with a negative to give me a negative value. Or a negative value times a positive value will also give me a negative value as well. So let's see. Where is f positive and the g negative? So it will be those two little squares that we're going to work with. So that x greater than minus 1 and x less than 5, and also this restriction less than 2. So let's work with the number line again. We have minus 2, minus 1, and a 5 over there. We're going to work with an open dot because there's not an equal sign over there. So for the parabola, it will be an open dot like that. And my other critical value is also at minus 2. Let's do that. So x greater than minus 1, less than 5 will be over there. Greater than minus 1, less than 5. Now, we're not going to work with that value because we need to take into consideration that we're working with a negative value of g. So it will be g less than minus 2. And where will that be? It will be over here. There's minus 2 less. We're always also looking for an overlap, but we see there's no overlap over here. So that one is not working. Okay, so no solution whatsoever there. Let's try the other one. Minus 2, minus 1, and 5 for my critical values. There it is. There it goes. Right. Now, we need to check where fx is negative and where g is positive over there. So we will see over here, there fx is negative and there it is positive. So let's draw our solution according to that. So less than minus 1, we go to the left, or greater than 5, we go to the right hand side. Now we need to jump to the positive of gx, a minus times a positive. That will be that one there. So x greater than minus 1, minus 2, sorry. So it is minus 2, and there it goes, to the right. We need to look for an overlap, Let's see if we find an overlap over here. Yes, let's check. And we will see, well, there's an overlap. There's an overlap there and there. Okay, that's nice. And also over here, there's an overlap starting at 5 over there. So let's rewrite them in a nice interval notation. So we have x element. Okay, let's choose this one first. We will see it starts at minus 2 and it ends at minus 1, but we're working with open dots, so open brackets. Or, and let's see what's happened here. We will see x, this element. We'll see we start at 5, and this continues to the right as far as we can go, to infinity. Open dot, open bracket, and also open bracket for infinity. Right, so what we have here is these two values, these two intervals, is actually my solution for where fx times gx is less than 0. Right, let's just clean the sheet and we're going to do a next example just now. Right, example number 2, what we have here is a parabola and a hyperbola over here. And the question is, for which values of x will fx times gx be greater than 0? Okay, this looks very intimidating with all these lines over here. But just remember that we're working with actual values and that is a y value times another y value, and we want to see where that value is positive, of course. So we do exactly the same. Let's create a little table. Like I said in the exam, we can do it much quicker than this. But let's do it slowly to make sure we know where this is going to. So we have an fx and a gx. And the first thing that we want to do is to get the x-intercepts to identify my critical values. Remember, my critical values is where y is equal to 0. And we will see here my x-intercept for my parabola is -3 and 4. Remember, that is where y is equal to 0. So it will be -3 and 4. For my hyperbola, over here, the only x-intercept that I can see is over there, and that is a third. It's a third. Let's write it down. Right. Now the next thing that we want to do is we want to see where these functions are positive and negative. So let's first go for positive. That means greater than 0. So where is fx greater than 0? Below x, that's negative. Above my x-axis, it's positive. So that part of my parabola is positive between -3 and 4. So it will be for x greater than -3, okay, to the right, and to the left of 4, x less than 4. That is where my parabola is positive. Now let's have a look. Where is my hyperbola? Where that is positive is. So let's see. Right here we see it's negative over here, but from a third to the right we'll see it's rising up. So we will see x greater than a third, but just be careful. We have got an asymptote over here where we have x equal to 1. So we cannot go past my asymptote actually, because immediately it will jump to the negative side. So we need to stop at my asymptote. So we need to say that x must be less than 1. I'm not allowed to touch the 1 at all. So just see what happens there. Yeah, we have two values as well. Now, because we have that 1 over there, I'm going to add another critical value 1 over there. You will see why that is necessary. Right. Now let's check where my functions are negative now. So it will be negative, actually the opposite. So it was positive over there. My parabola will be negative below the x-axis. So it will be x to the left of 3, to the left-hand side, and to the right of 4. So x greater than 4. Okay, let's be careful how we're going to deal with the hyperbola now. Negative. We will see from far to the left, my hyperbola is coming, and it's at number 1 over 3. I have my critical value. So we'll see for x less than a third, that is true. Because just to the right, it's rising up again, but it's stopping at my asymptote over here. As soon as I go over my asymptote, I will see it drops to the negative immediately. So just add that as well. So where x is greater than 1. Right. So that is where my restriction will be. Good. Now, once we gather all this information, let's use our number line again. Now, actually, we have 4 critical values over here. We have a -3, and there's my 4. Then I have a 1, that 1 over there, and a third over there. Right, this is not up to scale, but that doesn't matter. For my parabola, I have -3. We're working with not included values, so it will be an open dot. The 4 will be an open dot. And for my gx, also open dots. Let's just write it a little bit above the line, above the one that we're working with. Now, where is it positive? We will see greater than -3 going that side, and less than -4 that part. So that is where my parabola is positive. Where is gx positive? Let's see. It is where x greater than a third, less than 1. Okay, we will see we have that part. Now remember, we're looking for an overlap to get to my solution, and we can discover that. We will see very nicely that we have an overlap over there and over there. Let's write my solution. So x is element. We will see we start at a third and we end at 1 with open brackets. The third and the 1 is not included. Right, that's my one solution. Let's try the other one. So it's the -3, 4, third, and 1. There's my critical values over there. Okay, for F and for G. Right. We're multiplying now the negatives. Remember, positive times positive gives me a positive answer. A negative times a negative gives me a positive answer as well. So that's why we're going to do these two. Right. To the left of -3 and to the right of 4. And this one over here, x less than a third, x greater than 1, x greater than 1. And remember, we're looking for an overlap. Do we have an overlap over here? Let's check. Yeah, here we have an overlap. Here we have an overlap. They're at -3. And what do we have here? There's also overlap over there. Right, starts at 4. That's nice. So let's write them down. We have x elements starting from -infinity up to -3. Open brackets, they are not included. And let's see here, or x elements. So let's check this one out. We will start at 4 and it will continue to the right up to infinity, also open brackets. And that is my solution. That is my solution. For x element from -1/3 up to 1, or x element from -infinity to -3, or x element from 4 up to positive infinity. Right, while we are busy with this, let's try the other side as well. We've calculated where f and gx, the x values, where it will be positive, but let's calculate where it's just negative, just to do some more practice to this. Meaning, for which values of x will f of x times gx be less equal to 0? Okay, we've worked with greater than 0. Let's work with less equal to 0 now. We're going to make use of the same table to calculate this as well. Let's just remember, to have a negative number, what we need to do is a positive times a negative gives us a negative value. Or if fx is negative and gx is positive and we multiply that, we will also get a negative answer. Now, what does that help us? We're going to work through this table now and check where fx, meaning the parabola, where fx is positive and where gx is negative. That will give us the solution that we need. So we're going to make use of our number line as well. We have a -3 and we have a third. Then we have our 1 and then also the 4. Now we're working with less than equal to, so that means that our values will be included, meaning the -3 will be included, the +4 will be included, and then also the third as well. And wait, the 1 cannot be included because the 1 represents this asymptote over here. So we still need to exclude 1 as well. That is very important. Right. So let's check where fx is positive. Fx positive over here. So that is where x is greater than -3, less than 4. Greater than -3, less than 4. That means we have that value over there. Multiply by gx being negative. Gx is negative over here. Okay, so it will be x less than a third. X less than a third. So we're going that direction. And x greater than 1. X greater than 1. Then we go that direction. Remember, we're looking for an overlap on our number line. So let's see where there's an overlap. And we can see, well, here we have an overlap over here. Here we have an overlap. Okay. And we also see we have an overlap over here. Up to 4. There's an overlap there. So let's write down my x values. So we have x element. We start from -3 over here. And it ends here at a third. And both of these values are included in my solution. The other x, this part over here, is x element. We start from 1 and we end at 4 then. But in this case, 1 is not included, but the 4 is. Okay, just to recap on this again, why 1 is not included, because my hyperbola over here is not defined where x is equal to 1. So that's why we exclude that value as well. Let's check the other side now. So we have done with f positive, g negative, and we're going to swing it around now. So let's see. -3, third, 1, and 4, and still we're going to include the -3, include the 4, include the third, but we're not going to include the 1 for the same reason. Fx negative, so fx, the parabola negative over here, and gx positive. Gx is positive over there, so we're going to work with that square and that square over there. Right, it's just the other way around. X less than -3, x more than 4, and here we have x less than a third. Let's see, sorry, not that one over there. We need to look at a positive. X greater than a third and less than 1, so that one over there. Remember, we're looking for an overlap. Do we find an overlap over here? No, there's no overlap. So there's not a solution for this. So in this case over here, the only solution that we have is this part over here. Right. Yes, I hope that helped, and all the best for the rest of the day. Goodbye.